ahead, if you did not take the time to color in the 2 examples from yesterday, make sure you go ahead and color in the traditional programming red. Okay, make sure you color those in red to match all the ones on traditional programming. Okay. And remember, the key about traditional programming is that it is human coded. So this is where the human, remember, just as a reminder and review, so that when we have a quiz on this information, you understand you are looking for a keyword human programmed, and that will give away that it's traditional programming. The difference is that there is a human, they're programming step-by-step instructions, and the computer will only perform what it is coded to do. It's not going to do any other extra things. It's not going to add in anything. It is only going to do what it is programmed step-by-step to do. If a step is missing, then it's not going to be able to function. And your first side should be done. Step by step and human. Also, if you want to write a note to yourself about humans being important, that is something you can jot down just to remind yourself, and it's only going to do what you've coded it to do. Okay, it's not gonna, like we said, go above and beyond or fill in a gap like we talked about with the peanut butter and jelly. If you don't say take off the lid, it won't do that. And flipping our page to the other side, machine learning. As the name suggests, this learning is done by a machine. So it's a computer learning on its own. There is not a human involved in this method of coding or this method of AI. Okay, this is all done by the machine. So we're going to paste a definition there that represents that. It is going to be the one that says AI system that looks at patterns of data. So it's just going to look at a ton of different data, take it all in, and look for patterns. So that's what the computer will do. It will take in all the data and look for patterns. No human involved because it's scanning the data itself. Color it orange and glue it down. And again, the computer is doing the learning. And in the second row, okay, be careful with your glue because you're going to be turning this in. You don't want it to stick to someone else's. The second row is our 3 types of machine learning. So our first type is going to be supervised. Okay. Our second type is going to be unsupervised. And our third type is going to be reinforcement. And you're going to go ahead and color code these yellow, green, and blue. And then we're going to learn what each type of machine learning means. Okay, so all 3 of these are looking for patterns in data, but they do it in a different way. So in supervised, the computer looks for patterns in data based on labeled data. This is like the example where I show you pictures of cats, and they're all labeled cat, and you then can show the computer a random picture and it will say cat because it has looked at tons of images that are labeled cat, 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 and it starts to learn patterns about what a cat looks like. So then when you show it a random picture, it can identify whether it's a cat or not. Unsupervised learning is the opposite. It does not use labeled data. It does not have labeled data. So it would just be looking at pictures or data that does not have a label assigned to it. And it's just going to search for patterns and relationships in that unlabeled data. And finally, reinforcement is going to use trial and error. It's going to test something out. If that does not come back with a reward, then it will try something new. And if it gets a reward as its feedback, then it knows that's the right thing to do. So it's a rewards and penalty system. It's like, do I put, when you're playing tic-tac-toe, I could put an X in that box. Does that equal a win? No, it doesn't. So I put an X in a different box the next time. It keeps trying and learning from itself based on it trying, and if it gets the points or if it doesn't get the points. It would be trial and error. Each time it would try, and eventually, after enough trial and error, it will know the pattern to use. Okay, so that would be reinforcement based on trial and error. Right, so go ahead and color those to match the column they're in. And now we're going to talk about the examples that go with each. Under supervised, a prime example is in your email. When you go through your email, you can tell your computer, you can label it spam, like junk mail, or not spam. After these labeled data sets are collected, so after the computer sees what a spam and a not spam email looks like hundreds and hundreds of times, it will then on its own be able to say, oh, spam, not spam. It will be able to filter it. Same thing we said with the cat photos was an example. You show it a bunch of photos, labeled dog, labeled cat. You will be able to learn from those labels. And the final one would be like your Spotify or Netflix recommendations. All of those items in Spotify and Netflix have labels like the type of song, so rap, country, and you will then be able, if you listen to rap, the next song predicted for you to like would be maybe another rap song. Your YouTube views and things like that work the same way. Makeup video, it's going to suggest a makeup video. All of that data coded those labels into those videos and things that you watch. Okay? Color that yellow as well. With unlabeled data, you're looking for just patterns in sets of information. So when we get to the unsupervised learning, the examples that we're going to look at are a little harder to think about. If you go into a grocery store and you swipe your bonus card, it's collecting information about you. Once it's done that with, like, let's say 1,000 shoppers, it could take patterns in those shoppers and group them based on patterns that it finds. So had no labels coming in, you weren't labeled coupon shopper or over 50 shopper or likes creamer until after it notices patterns in the data, and then it can group based on, oh, all the people that live in this neighborhood tend to buy on Wednesdays, or all of the people this age really like 2% milk, and it helps them stock their shelves that way. I could do the same thing with traffic at a website or students that come into my classroom. I could look at your grades and your attendance over 36 days and make groups of you based on your study habits. I could predict that those who had good grades and perfect attendance would also be grouped into a group called good study habits. But I didn't know that about you before I started collecting the data on you. Okay? So that's unsupervised, which means unlabeled. Just think about unsupervised, unlabeled. Okay? The final is the most common with you, probably reinforcement learning. A lot of things that you access on AI probably use reinforcement learning. Our examples include a robotic vacuum like the Roomba. It's going to use trial and error when you get it. It will bump into walls. It'll learn that's not the way to go. So it will learn again and try again, and then it will learn the pattern of your house by trial and error, so that eventually, after enough tries and fails and tries and successes, it will navigate around your house without hitting in walls, for the most part. And the second is like your video games. When you do something good in a video game, you get points. Generally, when you do something bad, you lose a life, lose a level. AI Tic-Tac-Toe or Connect 4 is a really good example. If it plays enough games and realizes how to win and how to lose, which squares after a person plays, where should the computer play, then it learns how to win each game each time. And we'll be doing some experimenting with that when we explore our different AI sites. You can see how the computer AI version on tic-tac-toe wins almost every time because it's memorized where to go, because it's tried, it's failed, it's tried, it's failed in over thousands and thousands of games. It's been trained to know exactly what place to put its markers in so that it wins or ties every time. Very rarely does the person win. Okay? And so go ahead and color code those to match. Once you have finished color coding them, you can turn it into your drawer, make sure your name is on it, and make sure you put it in the right drawer. If your name is on the list for crossword puzzles, now would be the time to work on that and get that submitted, and the next agenda item, which is either code.org or again, missing work. Thank you.